Back, everybody. So I hope everyone had a good time with the exam. I am currently backed up on my grading for my classes, so I hope to have it to you next Monday, but I don't foresee it any earlier than that. Um, but we'll get. We're just going to keep chugging along. So we left off here in Unit 3.2. We were talking about the mean, medians, and modes, and so we had that one data set, but we didn't get to B. So we need to find the mean, median, and mode, the three different types of averages for the next set, which I've already got listed in order. So that's good. It's already in ascending order. Always be making sure of that. It doesn't do anything for you when it comes to the mode or the mean, because those things like the mean, you just add up all the numbers. It doesn't matter the order that they're in, and then divide by the total number of numbers. In the mode, you just looking for the total number, like the data entry that has the most the number that has the most data entries. But with the median, it needs to be in ascending or descending order. So this one's good already. So for part B, the mean, mu, would equal, so 5 plus 5 plus 5 plus 5. Or you could just do 4 times 5. It's your call. Plus 7 plus 11 plus 12 plus 13 plus 15. And how many data values is that? That is 1, 2, 3, 4, 5, 6, 7, 8, 9 data values. So we're going to divide by 9. And if we plug that into our calculator, you should get 8.6 repeating. So approximately 8.67 or 8.7. Let's round to one decimal place. 8.7. Now, when you have an odd number of data entries, the median is actually going to be a number. If it's an even number, then it'll be the two middle numbers averaged together. So since this is 9, it's odd, which means that the median is actually going to be in there. But I'd like to use my little technique for the median. So we take 9 divided by 2, you get 4.5. And since it's an n.5, that means we're going to get the median will be the fifth data entry. That's my little trick. You take your total number of data entries, divide it by 2. If you get a number, a whole number, like 4 or 5 or 10 or whatever, then it's going to be the n and n plus 1th numbers that give you your median. But if you get an n.5, so like 4.5, 3.5, whatever, then the next whole number is your median. So since we got 4.5, that means that the fifth data entry. If we'd gotten 6.5, the seventh data entry, and so on and so forth. So the fifth data entry for us then would be 7. Yes, very, very good. So I'm going to shut down this app and try again. Because it's sometimes this happens with Notability where it gets a little bit lagged when you have been using it too frequently. So fifth data entry, so that is 7. Much better. And then the mode, the quickest one to find, in my opinion, is the entry that has the most frequency, the most times it occurs, which in this case would be 5. 5 with frequency 4. You don't need to mention the frequency, but I want it to be mentioned because we're going to be talking about frequency tables in just a little bit. So, now that we've done some purely mathematical examples, let's add a little bit of real world aspects to it. So, example, Phil has scored an 87, an 88, and a 92 on his first 3 exams. What excuse me, what score does Phil need on his 4th exam to have a mean average of a 90? And we're going to round to the nearest whole number. So I scored an 87, an 88, and a 92 on the first 3 exams. What do I need to score on the fourth exam to make sure I get that A minus? Make sure that my average on my exams is a 90%, and then hopefully my homework scores have been doing pretty well, my quiz scores. That will just secure me in the A category. So there's one way to do it, which would be to just kind of keep messing around with numbers and figure it out. But that's no fun. That's a bunch of guessing. How about we try and find this out mathematically? So for the solution, we don't know what my 4th exam score is. Let's just call it X. So let X equal Phil's 4th exam. You could also write let X equal exam 4. Anything will be fine just as long as you know what you're defining your variable to be. So let X equal Phil's 4th exam score. We want the mean mu to equal 90. But the mean is adding up all the data entries. In this case, that would be 4 different exam scores and dividing by the total number. So what I've got then is I've got 87 plus 88 plus 92 plus X divided by 4 has to equal an average of 90. So we can solve this in a myriad of ways. The way that I'm thinking of it is I'm saying, well, I don't really like dividing by 4, so I'm going to get rid of that first. And so I will multiply both sides by 4 to cancel it on the left. And then we've got 87 plus 88 plus 92. That's 267 plus X is equal to 360. And then we want to solve for X. So we got to get X by itself. So we need to subtract off that 267. Canceling it on the left and get that X is equal to a 93. So as long as I score a 93 or above, I will get a mean average of 90 or above. Very, very useful thing in terms of doing grade calculations is making sure that I can't tell how many times students have asked me, like, what do I need to score on the final exam, or what do I need to score on exam number 1 in order to do that? Our calculations, because I weight the class based on the quizzes, grades, and stuff, is a little more challenging to do so, but the idea is still the same of trying to take the average of all those things and make sure that works out. All right. So I told you guys that the mean, one of the most important things that I want you guys to know about averages in this class is that the mean is heavily influenced by outliers. So as an example of this, there's a really cool online store called Jamazon.com. And they have 5 employees. Jamazon has 5 employees. 4 of them make $40,000 a year. And the manager makes $200,000 per year, which in actuality is not a bad spread for in terms of management. That's what it used to be. It used to be that a manager was paid anywhere between about 3 and 5 times the amount of the average employee for their company, but that's no longer the case. It's pretty egregious at the moment, but either way. And so that's the stuff that you can find on like Glassdoor or whatever. They have 5 employees, 4 of them make $40,000 a year, and then the manager makes 200,000. In a recent ad, Jamazon claims that its average salary is $72,000. Why is this disingenuous? I think you guys can already tell because only one person is making, like, that's nearly double what everyone else is making. But that's the mean average. If you do 40,000 plus 40,000 plus 40,000 plus 40,000 plus 200,000 and divide that by 5, you will get $72,000. And so they're touting that they have an average salary of $72,000, whereas most of the employees, if not like basically all of them, are making just 40 grand a year. So the solution, the reason why this is disingenuous is they're using the mean average which is greatly affected by the $200,000 outlier. The median would be a far better representation. Median, of course, would be $40,000 a year. The median would be a far better representation because most employees, in fact, 80% of the company makes $40,000 a year. So that is why we need to be careful with the mean. When people say average, you should always be asking, like, what type of average? What type of average are you talking about? And then looking at the data set as a whole, if you can. I know that's a lot to expect for just every situation where an average gets used, but another example would be like if you're looking at cars, especially here in Vegas, it's something I've definitely noticed since moving here is that it's a big emphasis on the flashy cars. See a lot of people driving those Ferrari SUVs and stuff like that, which cost more than most homes, which is interesting. But either way, if they were saying the average cost of a car in Vegas, there'd be all those cars, those Ferraris, those Lamborghinis, those very nice expensive cars that would heavily skew the mean average to suggest the average price of a car here in Vegas is much higher than it actually is. So, anyways, any questions on that? The mean is heavily influenced by outliers. Okay. Next little topic are frequency tables. Definition: a frequency table is a data set or is a data table used to represent large data sets by breaking up the values based on their frequency. So it's a way, if let's say you have a lot of repeats, like you have a lot of people, like if it's the scores on a Scantron exam, right? For maybe like an entire school aptitude test or something like that. And so there's no like half points or anything like that. So people are either getting like 15, 25, 72, whatever. And they're getting like a lot of people might be getting the exact same scores. And so instead of writing it out as this big 1,000 long data set, we can write it succinctly as a frequency table. So as an example of this, to see how it relates, here's a frequency table. And then here's the corresponding data set. So frequency tables typically look like this. They say like a data entry, a data value, whether that data value is like the number of students, number of people getting like the scores on an exam, whatever it may be. The data values go in the left column, and then frequency over here. And so let's say the data values are 15 with the frequency of 2, 31 with a frequency of 1, 50 with a frequency of 4, and 86 with a frequency of 2. Once again, 15, 2, 31, 1, 54, and 86, 2. So the corresponding data set for this is just listing out all the data values with their frequencies. So that would be 15, 15. Because 15 has a frequency of 2, it show up twice in the data set. 31 has a frequency of 1, so it only shows up once. Then 450s. And then 286s. So that's how a frequency table works. It takes in and this is a very, very small data set, right? That's only 9 data values. But this would be more likely used for situations where you have a lot. You have a lot of them. This is actually how this is closely related to GPA, which we'll get to in a second. So, any questions on how a frequency table gets set up? Okay, let's look at an example of using one. The following frequency table displays the number of students in classes at an elementary school. Find the mean, median, and mode. Find the 3 averages. All right, let me create that little table for us. So it says students and then frequency over here. So 14, and then 9, 17, then 7, 21, then 8, 26, then 3, and then 28 and 2. So when I first, I'll let you guys write this down. So once again, the students column is 14, 17, 21, 26, 28. Frequency column is 9, 7, 8, 3, 2. How do we interpret this data? How do we look at it? Well, what it's saying is that there are 9 classrooms with 14 students in them at this elementary school. There are 7 classrooms with 17 students in them, 8 classrooms with 21 students, 3 classrooms with 26, and sadly, 2 of them with 28. It's way too many kids for just one teacher to deal with, especially in elementary school. I'm currently trying to help be like a side coach for my son's little league and trying to get, and their practice is at 6:30 at night. I don't know if anybody has any kids or knows anybody who's 3 years old. They're not able. It's like herding cats. Like they are. I try to get them to do anything, and there's only 6 of them. There's only 6 of them, and it's chaos. Imagine 28 of them. Oh my God. Just so we're understanding what this is saying. This means there are 9 classrooms that have 14 students in them. So the frequency always means the number of times it occurs in the data set. And then the other thing is the thing that's being measured. So it should always say frequency. There should always be a column type of frequency in these types of things. So hopefully that's starting to stick with how you're supposed to interpret that graph. So now we need to work on the mean, median, and mode. So right off the bat, there are 9 plus 7, that's 16, plus 8, that's 24, plus 3, that's 27. There's 29 data values, right? So I'm just going to kind of make that a mention. 29 total data entries. From adding up the frequencies. So if you're looking at this data set, it would be 14, 14, 14, 14, 14, 14, 14, 9 times, and then 17, 7 times, and then 21, 8 times, and 26, 3 times, and then 28, 2 times. So if I want to know how many data entries, I can just add up all the frequencies. That's going to be useful for both the median and the mean. So for the mean, you've got, so yeah, we could do it the old-fashioned way, 14 plus 14 plus 14 plus 14 plus 14. But who wants to write out 14 9 times and then 17 7 times? Who wants to write down 29 numbers? That seems unnecessary. And it is, because multiplication is just iterated addition. So instead of writing 14 9 times, you could do 14 times 9 plus 17 times 7 plus 21 times 8 plus 26 times 3 plus 28 times 2. And then divide that by 29, making sure that your entire numerator is in parentheses if you want to calculate this all in one go, or you're using the fraction button. And no matter how you do it, you should get 18.862, but we can't have 0.86 of a student, right? Maybe a kid's slightly sick and they're only working at 86% capacity. And so approximately 19 students in each classroom. Sure, we'll use a trapezoid. Why not? That's the mean. The median is probably the hardest one, in my opinion, to find with a frequency table, because I don't want to write out 29 data values. You could, and then use the trick of going inward, right? Like you could write out 14, all the way to 28, and then start doing the canceling thing to try and get to the middle. But that seems like it's going to be very, 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 very tedious. And this is only 29 data entries. What if there were 300? What if there were 3,000? That would be very, very tedious to try and write down. So that's why I've taught you that technique of dividing by 2. So for the median, (29 entries divided by 2 gives you 14.5. And since it's a 0.5, it means that the next whole number, 15, will be the median. So 15th entry is the median. Okay. So the 15th entry is the median. Which one's the 15th entry? 17. And we got that, yes, by looking at the fact that you'll have 9 14s, and then your 10th entry through your 16th entry will be 17s. So the 15th entry has to be the 7. So the median is 17. Any questions on that? That's kind of the weird one. The nicest thing about frequency tables, though, is that modes are very, very quick to calculate, especially since they're not even jumbled at all. Mode is going to be 14 because that one has the highest frequency. 14 with a frequency of 9. Any questions? Okay. Something that you guys will probably actually be interested in is a type of frequency table that we discussed, which is a GPA. Have you ever wondered how they calculate your GPA? Now, where I went to school at the University of Washington, they didn't do an B, C, D, E, F system. They did a 4.0 scale. So here we do a letter grade system, and then we convert that to a GPA. And so an A is always a 4.0, but it doesn't specify between the different types of A's. So a 99% or 100% A, it gives you a 4.0, just like a 92.01% gives you an A. In a 4.0 scale, to get a 4.0 GPA is damn near impossible. So anyways, the way we calculate it is based on grade points. So grade point average. So I'm going to make a little chart here. You don't have to write it down if you don't want to. If a type of problem like this occurs on the exam, I will be sure to give you guys this chart to follow along with. So grade and value. And then I'm going to do big line because we're going to need to do, and then grade, and then value again. So if you want to make the chart cool, and this is what it's going to be. So an A gives you a 4.0, an A minus is a 3.7, a B plus is a 3.3, a B is a 3.0, a B minus is a 2.7, a C plus is a 2.3, a C is a 2.0, a C minus is a 1.7, a D plus is a 1.3, a D is a 1.0, a D minus is a 0.7, and an F is a 0. So when you take a class, there are different credit sizes, right? This class is a 5 credit class, whereas, I mean, technically it's 5 credits, but really there's only 3 credits of college class. The Math 20 component is a co-requisite course that doesn't give you a grade. So the co-requisite part doesn't give you a grade. But regardless, some classes like calculus are 4 credits. Some classes are 5 credits. And so they get weighted differently. And so this is actually something that happened in grad school, which was very, very frustrating for a lot of people. At least in the math department, if you're in grad school, if you got below a 3.0 GPA, you were out of the program immediately. No matter what semester it was, if you got below if your GPA dropped to a 3.0 or below, you got kicked out. And that was all fine and dandy. Like, sure, okay, we can just make sure that we're always working really, really hard. However, it happened to several students. They were forced to take a 5 credit and a 3 credit course, and that was it. And if you got a C in this course and an A in this course, you'd immediately be kicked out because that 5 credit course gives you more GPA points. So that was a big problem. They actually had to make an amendment to that system. But either way, to calculate GPA, for each course, take the associated value for the grade and multiply it by the number of credits. Then divide the sum of those by the total number of credits. This is something I'd like to ask you because I don't have the student view on my CSN and things like that. Does it tell you your GPA automatically? It doesn't? Okay. That was gonna be my first question. My follow-up question was gonna be, does it tell you your major GPA? Because at least uh, at at UW, they didn't do that. They just told me what my overall GPA was. But if you're trying to apply for grad school, your overall GPA doesn't mean diddly squat. They don't really care if you flunked out on Drama 101 and that lower your GPA. They really just want to care about your major GPA. Like, what did you get in your math courses? That's their most important thing. So on my resume, when I was applying for colleges, I had to write down my major GPA, and I used this to calculate it. So really what it is it's just a frequency table for each of these things. And then you're finding the mean average. So as an example, suppose Phil got an A in his 4 credit, so 4 CR math course, because of course that's my major. A D in his 3 credit English class. Never was very, very good at it. Poetry sucked. Kidding. It was a pretty fun class. A B plus in his 2 credit dinosaur class. Best class I ever took. Very, very fun course. I got extra credit for going to a museum, looking at dinosaur fossils. Highly recommend if you can take that class, or volcanoes. Volcanoes is also very fun. And a C plus in his 4 credit sociology of murder class. Terrible class. Would not recommend. I was so excited to take it because I thought, like, sociology classes, kind of studying how society works, and I was going to find out about murder and, like, Ted Bundy and all those things. I thought it was going to be a super fun class. Nope, it was just about statistics. Did you guys know? Did you guys know that you're more likely to be killed with a gun or a knife than any other weapon? That's what I learned in that class. And that most murders happen are started by men. Who knew? Who knew? These are surprising things that I'm glad I wasted over several $1,000s taking that class. My friends took sociology of sports, and I envied them for that. That was a way more fun course. But sociology of murder, not a fun course. Don't recommend. Maybe it's different here. So determine Phil's GPA. To 2 decimal places. Typically, we either do 1 decimal place or 2 decimal places when we're representing GPA. All right. So I'm going to copy this down for us. Don't worry if you haven't finished writing. I'm going to I just want to have our GPA scale. What happened? Oh, I got disconnected. Give me one moment. Lovely. Pause. Okay, fixed it. Cool. So I like to make a little chart to figure these problems out. So I got my grade, my GPA value, and then I've got my number of credits. So I got an A in my math class, which means based on the chart, that's a 4.0, and there were 4 credits of that. So I got 4 credits worth of A's, and then I got a D in my English class. A D corresponds to a 1.0, and that was for 3 credits. So I've got 3 credits worth of D's. And then a B plus, which is a 2.7. B plus is a 3.3, excuse me. And there were 2 credits there. And then I got a C plus, which is a 2.3 in my 4 credit sociology class. So I'm going to try and find my total number of GPA points and then divide that by my total credits. So for my GPA points, it's going to be 4.0 times 4 credits worth of that plus 1.0 times 3 plus 3.3 times 2 plus 2.3 times 4. Because basically what we're doing is we're creating a frequency table. We're saying that I got like there was a frequency of 4 for the 4.0s, there was a frequency of 3 for the 1.0s, there was a frequency of 2 for the 3.3s, and there was a frequency of 4 for the 2.3s. And so if I add those all together, I get my total number of GPA points, which is 34. Let me triple check this because I always try and mix up the numbers. 4 times 4 plus 3 plus 3.3 times 2 plus 2.3 times 4. 34.8 points. And then I also need to know the total number of credits. Total credits would be 4 plus 3 plus 2 plus 4, which is 13. So just enough to make sure I'm a full-time student and I get that financial aid. So my GPA then is just taking my total number of GPA points and dividing it by my total credits. 34.8 divided by 13, which is equal to a 2.68 GPA when all is said and done. It's like a 2.6769, so blah, 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 but we're going to round it to the nearest two decimal places, which is 2.68, which corresponds to a C plus. Is it the minor, like the N cutoff for a B minus is 2.7, so I'll pray that the course is curved just a smidgen so that I get that B minus. And that's how you calculate GPA. Any questions on that? And it kind of makes sense if you think about it. So once again, this ensures, so you don't just average your course grades on each class, because that would make it so that a 5-credit course and a 1-credit course would weigh the same. So you multiply by the number of credits to make sure that each thing is weighed the same amount. Okay. Any questions on that? Okay. So then we're going to start off a new section, which is section 3.3, which is on percentiles, quartiles, and box plots. I'm sure you guys have already heard about percentiles and the like. Quartiles, maybe not. Box plots, maybe. You might have also heard of box plots called cat and whisker plots. But we're going to start off with percentiles and their calculations. So, overall rank versus percentile rank. Definition. This is kind of a two-part definition. The overall rank is the position of a data value in an ordered set with rank 1 being the highest. Overall rank, and like we're just finally getting a name for this course, but you've seen overall rank all the time. Some examples of this would be like the position in a tournament, position / place in a race or / tournament. So like winning first place or second place or 13th place or whatever it may be. That would be what your overall rank is measuring. It's measuring where you are in relation to rank 1, the highest rank that there is. Like first place. Versus percentile rank. The percentile rank is the percentage of data entries that fall below a given data value or data entry in an ordered set. So the percentile rank is the percentage of data entries that fall below a given data entry in an ordered set. So both of these situations, they require it being an ordered set. As an example of this would be SAT scores. Or baby heights / weights. If or when you have kids, that's one of the things that when you have a newborn, that like, oh, your baby's in the 40th percentile of height, but in the 90th percentile of weight, or all that stuff. And you just try and hold on to anything during that newborn stage because it's rough. And so, yeah, my baby's in the 90th percentile of heights. What about yours? Neener. Which really means absolutely nothing. But either way, it's one of those things, just trying to give parents something to be excited about when their baby has colic, which I don't wish that on my worst enemy. But if you've ever taken the SAT or the ACT, they usually give you kind of a chart when they give you your scores back, and they tell you what percentile you are in. And that's really telling you what percent of people are below you on average. So like if you score in the 89th percentile, that means that of the people that took the SAT, 89% of people scored below you. And so how you calculate percentile rank is equal to the number of data values below divided by the total number of data values. So percentile rank, you find out how many people are below you, and you divide by the total number of things in your set. That is how we calculate percentile rank. So as an example of this, let's say that Johnny see here. Well, I'm trying to make this up on the spot because I forgot to print out a worksheet for you guys, so I'm making these ones up. So Johnny scored better than 326 of his 489 classmates. What was his percentile rank? So the difference between overall rank and percentile rank is very, very important. Percentile rank is found by the number of people below you, whereas overall rank is based on how many people are above you, right? If you scored fourth place, that means that there were 3 people who did better than you, right? That's how we kind of determine overall rank, whereas percentile rank is looking at everyone below you. So his percentile rank will be 326 divided by 489. So 326 divided by 489, which gives you 6 divided by 489, gives you, wow, that's amazing. That's exactly 1/3. That's nuts. No way. Sorry, 2/3. I just picked 2 random numbers. I just picked 2 random three-digit numbers, and it ends up simplifying down to 2/3. You know how rare that is? You know how rare it is to have that happen? Where you just choose two random numbers? That's amazing. I'm in awe. Wow. Wow. What a day. Okay, so that's 0.6 repeating. So that's approximately 0.67. So we don't write our percentile when we're answering problems, right? When we're dealing with percents, we don't write it as the decimal version. We write it as the percent version. So 67%, a 67th percentile. So Johnny scored better than 67% of his colleagues. So in this one, I gave you how many people scored below Johnny. But what if I gave you their overall rank? So as another example, let's see here. Jesse got, someone give me a prime number. 13. Perfect. 13th place. 13th place in a race with someone give me a three-digit number. 563. With 563 people. What was Jesse's percentile rank? So because it says that their overall rank was 13th, that's telling me that there were only 12 people above, or 13 people, including Jesse, that scored above Jesse. So if we need to find the percentile rank, we need to know the amount of people who scored below Jesse. So first, need number of people who placed lower than Jesse. But that's not too hard to do. We take 563 and we subtract off the 13 people, including Jesse herself, or their self. Jesse's kind of a gender fluid name. So we take 563, subtract off the 13 people, including Jesse, that scored above Jesse, and that gives us 550, right? 550 scored below Jesse. I did this because that's how percentile rank works. It takes the number of people below divided by the total number of people. So 550 divided by 563 equals 0.9769 . So approximately 0.98. So the 98th percentile. And so we don't write the percent symbol because this is a percentile, not a percent, but they are very, very closely related. It is a percentage, but because we're talking about it like in terms of a specific concept of percentile rank, we write instead of 98%, we write 98th percentile instead of writing the percent symbol. Any questions on that? Okay, let's do another example where we go in the reverse direction. Let's see here. Um, um, Someone give me a name that starts with an A. I can't think of anything right now. Amanda. Amanda scored in the someone give me a two digit number. 26. Scored in the 26th percentile on a statewide math test. If 407,268 students took the test, what was her overall rank? Okay. So we need to make sure we understand what we're doing here. So we need to know the number of students. In order to figure out their overall rank, we need to know how many students scored above and below us, how many students scored above her. So 26th percentile means she scored better than 26% of students. This is a percent problem. 26% of the student populace that took that exam. So I'm going to do 26%, so 0.26 times 407,268. That's a big state if there's 407,000. That's pretty obscene. Maybe a nationwide instead of statewide, but too late. So A is equal to 0.26 times 407,268, which gives us 105 approximately. So it's actually going to be exactly 105,889.68. So the question then becomes, do we round up or do we round down? Because what it's saying that what this means is that there were 105,889.68 people that scored lower than Amanda. So the question is, do we round up or do we round down to include that additional person, or do we not include that person? And that is subjective. In this class, we're always just gonna round like normal. For this class, round like normal. However, if you decide to say that it should be 105,889, you're not going to include the 0.68, you're going to round down, I would still give you full credit because there is an argument either way of why it could be one over the other. But for this one, for conventional sake, we will round to the nearest whole number. We'll just follow normal rounding techniques. So approximately 105,890, that is, students scored below Amanda. So her overall rank is not 105. Her overall rank is not 105,890. That's the number of students who scored below her. We need to know the number of students who scored above her. So number that scored above. Amanda. That's going to be 407,268 minus 105,890. And so 407,268 minus 105,890 gives you 301,378, including Amanda. And so this is also one of the kind of gray areas is, do we include her in the 108,000? Like, is this including Amanda, or does that mean that she is 105,891? That is the question. Is she the 105,891st person in this data set, or is she the 105,890 total? And so with me in this class, if you try, like, I would argue that like she's part of the people that are above or including. So I would say that her rank would therefore be 301,378th place. Now, granted, I don't think really in the grand scheme of things, if there's 407,000 students, whether or not you're in 301,378th place versus 377th or 379th place, I don't think that's much of a difference. So I don't think, in my opinion, that it matters that much in this context. But regardless, if it's on an exam, if this type of question's on the exam and you decide to round differently, I'll be looking out for that. So I will give you full credit regardless based on you, because there are many arguments to say which one should be the right one. I would probably say that if you rounded up, then you'd be including her in that 890. You'd be including her in the students that scored low, whereas if you round down, she's going to be the 105,890th. So either way, I'm just saying that I'm mainly trying to tell you that there are ways to interpret this data a little bit differently, but for simplicity, we're just going to round, and then whatever number we get, that's going to be the place. It's kind of like those situations where like it's really unnecessary nitty-gritty details. For example, in my calculus course, we start talking about some physics applications, and I don't want to make my students do unnecessary unit conversions when I'm trying to test them on calculus. So I don't want to test you on unnecessary semantics when I'm just trying to test a math concept. Yes, Grady.
If 301,378 people scored above her, would that make her the 379th place?
So that comes into play of whether or not we're considering her to be part of the students that scored below Amanda, or part of the students that scored, or if she's not in that. So if we are assuming that she's part of it, then it would probably be the 301,379th place. Let me restate that. Let me just make sure, because this one always messes with me as well. So if we were including her in the 105,890, then that would actually be her place. But if we're not including it, then it would be the 79th place.
So if we do either on the test, we get full credit.
Yes, you will get full credit for either one. And if it like I believe so this course is standardized for CSN for the most part. So I try to stick with a bunch of my other colleagues, and so the homework assignment for this class is pretty consistent. And I believe there's a margin of error on the problem, so that if you answer like one or two off, it'll give you full credit. But if that's not the case, send me an email and I'll give you full credit back on the problem. So if there's a problem on the homework or the quizzes that like you're one number off by, you're off by one data value, let me know and I'll give you full credit back. Thank you for asking that. Okay. Any other questions on percentile versus overall rank? Alrighty. Then we'll talk about quartiles. Definition. So this is a 4-part definition. Number 1, quartiles are a way of splitting a data set into 4 categories of roughly equal size. On occasion, there might be a situation where one of the quartiles has like 1 or 2 more people or like 1 or 2 more data values than the others, but few and far between. So this is where I do want, I'm going to stick with what the book decides to use for their notation, but I'd like to express my choice to use a different notation based on your opinion. 2, the first / lower quartile. Oh, I meant to write that in red. The first / lower quartile, which we abbreviate as Q sub 1. That's the way the book does it. But I would prefer to write Q sub L. Because when you say first quartile, you could mean like the upper first, like the first place, or you could mean the low, like the lowest point of it. And that's very, very ambiguous. So I like to use the terminology Q sub L, but the book uses Q sub 1. So I'll write that on like I'll probably write on the exams, like find the different quartiles, Q sub, and I'll write Q sub 1 or Q, and then like maybe underneath it say or Q sub L or something like that, so that it's not ambiguous. But first quartile is the median of the lower half of the data set. 3, the second or middle quartile is the median of the set, the median of the entire set. So we're going to either abbreviate that as Q sub 2 or as capital M for median. And as you can imagine, the last one, the last definition is the third or upper quartile. Which is either Q sub 3 or Q sub U. I'd prefer to use Q sub U because then when I think third quartile, I think like third place, and I'm thinking it's the lower quartile, but it's actually the upper quartile. So I don't know. Sometimes mathematicians aren't really thinking clearly. The median of the upper half of the data set. So and I know what you're thinking. That's if quartiles meaning 4, right? Quarter meaning 4, or 1/4 rather. Why do I only have 3 things? Well, 3 numbers would split up a whole data set into 4 equal parts, right? If I have 1 whole and I split it up with 3 lines, I have 4 equal parts. So there's 3 numbers. There's 3 different numbers. There's the first quartile or the lower quartile, the middle quartile, the median, and the upper quartile, the third quartile. So that gives us the concept of a 5-number summary. 5, I guess. A 5-number summary is a way to represent data with 5 key values. So this is a very, very good way to look at your data because it splits it up into equal parts and gives you a sense of where most things are. So in particular, you look at L, which is your lowest value, Q sub 1 or Q sub L, which is going to be the first quartile, Q sub 2 or M is equal to the median, the second quartile, Q sub 3 or Q sub U is the third quartile, and then H is going to equal the highest value. That's a lot of writing. L is your lowest value, Q1 is your first quartile, Q2 or M preferably is your median, Q sub 3 or Q sub U is your third or upper quartile, and then H is your highest value. So essentially, what it does to a data set, this 5-number summary, is imagine if I was just writing all of my data values in this little box. That's a box, apparently. Thank you. Okay. Need to control my blood pressure. Anyways, so the median would cut the material exactly in half. This is where the M is. The lowest data value is L on the left-hand side of your data. The highest value is on the right half of your data. And then Q1 and Q3 divide the other 2 pieces. This is Q1. And let's use blue. Q3. So it splits it up into 4 equal parts, all with 25%. So this would be the 25th percentile. The median is the 50th percentile. And Q3 is the 75th percentile. So let's write that. Let's come back to that in just a moment. Once everyone's done writing it, I know I write a lot of stuff here, so. And this is where we're going to stop. By the way, we're not going to do an example because there's not enough time for it, but I just want to talk about this after you're finished with it. And we'll probably get out a couple minutes early. So what this is trying to do is break up your data so that you know where people are placing. So if a student, let's just use exam scores because that's an easy one to visualize. If a student scores between the third quartile and the highest value, you know that they're at least in the 75th percentile, if not more. Similarly, if they're in this little subsection, they're between the 50th and the 70th percentile, depending on where exactly they land in that little spot. Similarly, if you score in between the Q1 and the median, you're somewhere between the 25th and the 50th percentile. And then last but not least, if you're between the lowest value and Q1, you're in you're either at the 25th percentile or lower. So it's a way to look at your data in a way that is very, very simple. You can just look at 5 numbers to kind of visualize what's going on. As a teacher, when I could look at a 5-number summary and say like, okay, so the highest score on my exam was an 89. So I'm going to curve my exam appropriately. If nobody got like in the 90s, that's something that would indicate to me that something's, maybe I made the exam a little too hard. Maybe I should have listened to my wife and took out that one problem that was way too hard. Frequently, she checks my exams and says, Phil, that question was way too hard. You need to get rid of it. So, anyways, that'll do it for today. And for this week, even we were expected. Think the homework for 3.3 was technically due this week. Wait, let me look at the calendar. It's next week. I'm pretty sure I assumed that we were going to continue on Monday of next week. Let me check that real quick. Yeah, so the homework is just 3.2 for this. No, there's nothing except for 3.1. 3.2 we do next week because you had an exam this week. Let's take it easy. Okay, guys. If you have any questions, feel free to email me. Otherwise, you guys have a great rest of your day, a great weekend, and I'll see you guys on Monday.